Good morning, one and all. Now I am going to discuss about information extraction and reconstruction and fusion view and all. In last class, we discussed about reconstructing software architecture, introduction about it. We are discussing so many points here. And also we discussed about importance of workbench approach, and we discussed about reconstruction activities like information extraction and database construction, view fusion, and reconstruction. So we discussed about introduction of those four reconstruction activities, and also I explained you in detail about this particular figure or diagram regarding to architecture reconstruction activities. Pavan, leave ma. This is recording class. Okay. So this is a very important concept. We have to reconstruct the software architecture. We need to follow these four types of activities. And now we are going to discuss about the information extraction. Okay, information extraction means nothing but we have to extract the information. We have to get the information from different sources. That is the meaning of information extraction. Okay, so that is what so here the information extraction involves analyzing a system's existing design. So here we are extracting the information related to the particular existing design, okay, and implementation artifacts to construct a model of it. Okay, we want to construct one architecture, so we are analyzing the information regarding to the particular existing system design and implementation artifacts. Okay, now that is what information extracts involves here. Based on analyzing, we have to extract the particular existing design and implementation artifacts to construct a particular model. The result is a set of information placed in a database. What is the result? A set of results information placed in a particular database, okay, which is used in the view fusion activity to construct a view of the system. Okay, now it is used to in the view fusion activity. So where we want to construct a particular system regarding to the views. Information extraction is a blend of the ideal. Okay, na? Means what information do you want to discover? So we need to know which type of information we want to discover about the architecture, and that will most help you meet the goals of your reconstruction effort. So when the particular persons or particular architects reach their goals, where we want to reconstruct, okay na? So we want to reconstruct a particular area. Which type of information we required, we need to discover according to the particular architecture, then they meet their goals of reconstruction effort. And practical, then they will be put into a practical. What information can you or available tools actually extract and present, then we can think about which tools they are using to extract the particular information and for present from the source artifacts. For example, we are having different types of source artifacts and other artifacts also. So the source, so for example, for source artifacts, code, header files, and build files. For other artifacts, for example, execution traces, you can identify and capture the elements of interest within a system. These are useful for identifying and capture the elements for interest within the system. For example, within a files, and by using the functions, by using the variables, okay, and based on those we can perform and their relationships to obtain several database system views. Okay, and also they can obtain the several relationship among the particular system views. Each of the relationships sorry ma, between the elements gives different information about the system. For each and every relationships between the elements, they can give the information, they can give the different types of information about the system. In general, the individual elements have their own function, sorry, but when you are having choosing the relationships among them, they also give the different types of information. The calls relationships between functions help us to build a call graph. For example, the calls relationships between functions, this will be help us to build a call graph. The includes relationship between the files give us a set of dependencies between system files. That is the most use of the particular information extraction. For example, we want to read and we want to write something. We are using access read and access write files. Okay, now we want to read something, we are using access underscore read. We want to write something, we are using access underscore write functions. Okay, now and these are the having some relationship between the functions, and variables show how data is used. So according to the variables, they can shows the how we are using the data. Okay, now certain functions may write a set of data and other may read it. This information is used to determine how data is passed between various parts of the system. So based on by using these type of different types of functions, different types of files, we can know how the data is going to be passed between the various parts of the system, and you can determine whether or not a global data store is used, or whether most information is passed through the function calls. So we need to know the information is passed between the function calls either globally or not. If the system being analyzed is large, we want to be analyze a system, it will be large, and capturing how source files are stored within the directory structure may be important to the reconstruction process. And certain elements or subsystems may be stored in particular directories, and capturing relations such as dir underscore contains underscore file and dir underscore contains underscore dir is useful when trying to identify elements later. We want to capture in the particular elements or subsystems may be stored in a particular directories. So we are using we want to know the relationships, we want to catching the relationships, we are using such a type of directories. For example, dir underscore contains underscore file and dir underscore contains underscore dir is useful when trying to identify elements later. And also the set of elements and relations extracted will depend upon the type of system being analyzed. So we want to extract some set of elements and relations, it will be depends upon the type of system being analyzed and the extraction support tools available. So we want to extract after analyzing among the set of elements and relations, they can using different types of supporting tools, they are available according to particular analyzation. If the system is to reconstruct, for example, the system is to be reconstructed, is object oriented based on this information. So based on these relations, whatever the information they are getting, they are going to be, for example, reconstructed. So if the system is reconstructed, for example, we can think if the system is reconstructed, it is to be a object oriented, definitely it is a object oriented, and it will be having different types of interfacing classes, and also it will having different types of methods, okay na, are added to the list of elements to be extracted. And relationships such as class is underscore subclasses underscore of underscore classes, and class underscore contains underscore methods are extracted and used. So we want to add more information to the list of elements to be extracted. We want to know the relationships among the such classes or subclasses. We are using these type of syntax files. Those are class is underscore subclasses of underscore class, and classes underscore contains underscore methods are extracted and used. And information obtained can be categorized as their static or dynamic. So we want to get the information, it can be categorized in two ways. They are static or dynamic. Static information obtained is nothing but is only the system artifacts. We want to obtaining the only information related to the system artifacts, while dynamic information is obtained by observing how the system runs. That is the variation between static information obtained and dynamic information obtained. What is meant by static information obtained? It's only observation among the system artifacts, but dynamic information obtained is nothing but it is observing how the system is run. That is must and should. We have to know what is the static information obtained and dynamic information obtained, and the goal is to be fused, but both to create more accurate system views. Okay, that is the main goal. And for example, if the architecture of the system changes at runtime, and also, for example, a configuration file is read in by the system at startup, and certain elements are loaded as a result. That runtime configuration should be captured and used when carrying out the reconstruction. That is the main importance of information extraction. Here we are using different types of extraction tools. Okay, na? To want to extract the information, we are using variety of tools. They are parsers. Already we know what is the parser, what is the importance of parsers, how many types of parsers we are having. LALR parsers. Okay, na? We are having different types of parsers. Okay, na? Top down parsers, bottom up parsers, okay, na, LALR parsers, LLR parsers. We are having different types of parsers. We studied in computer graphics subjects, easy. Okay, and also, for example, here Imagex and Sniffix plus CIA and Resi parsers. These are the examples for parsers. These are the tools we are using. Okay, na? And abstract syntax tree analyzers, and also another tools are abstract syntax tree parsers. In short, we call it as a AST. For example, Gen plus plus parse and refiner. Okay, na? Analyzers and lexical analyzers. For example, LSME. Okay, na? Lexical analyzers. Next, profilers. For example, gprof. Okay, na? Profilers and code instrumentation tools, and head hoc tools. For example, grep perl. Okay, now these are the different types of different variety of tools we are using to extract the information. For example, parsers and abstract syntax tree analyzers and lexical analyzers and profilers and code instrumentation tools and ad hoc. For example, we have to think parsers. The parsers analyze the code and generate internal representation from it. That is the importance of parsers. They can analyze the code and generate the internal representation from it for the purpose of generating machine code, where you are using these parsers for the purpose of generating the machine code and intermediary code also. And lexical analyzers, so they are examining source artifacts purely as strings of lexical elements or tokens, and the users of lexical analyzer can specify a set of code patterns to be matched and output. That is the importance of lexical analyzers. Next, profiling and coding coverage analysis tools. They can be used to output information about the code as it is being executed. So it will, these tools are used to analyze the regarding particularly for output information, so about the code as it is to be executed, based on the code how they are going executed. So that type of output information we want to analyze, we want to get, we are using these profiling and code coverage analysis tools, and usually do not involve adding new code of the system. The tools to analyze design models, build files, make files, and executables can also be used to extract further information as required. So these tools also used to analyze the design models, and those are used to build the files and make the files, and executables can be also used to extract further information as required. That is the very much important regarding to the what is the main use of these tools. Okay, now for instance, build files and make files include information on modules or file dependencies. So for example, you have to consider the build files and make files, which type of information they are having. They are having the regarding modules and file dependencies that exist within the system and may not be reflected in the source code, and much architecture related information may be extracted statistically from source code. Compile time artifacts and design artifacts. Okay, now these are the two, mainly we are having compile time artifacts and design artifacts. Some architecturally relevant information however may not exist in the source artifacts because of late binding. Okay, na, so we are not sometimes may not be exist the source artifacts because late binding. Okay, for example, the late binding include the following, where the late binding mainly occurs in polymorphism and function pointers and runtime parameters. So what are the examples for late binding? So first one is polymorphism, second one is function pointers, third one is runtime parameterization. Next, database constructions. After extract the information, that extract information is going to be converted into a particular design format and standard format to store in a particular database during database construction. That is the main theme of database construction. Whatever the information we are extracted, let's say here, what is that? The external information is converted into a standard format for storage in a database. So any information we are gathered, that is going to be stored in a particular place, that is database, in a particular standard format. Okay na, database lo మనం డేటాని స్టోర్ చేస్తున్నామంటే ఇట్స్ మెయింటైన్ సమ్ స్టాండర్డ్ format like tables. For example, here the logical structure of database is tables. We need to follow some standard format. So that procedure is called, during that procedure is called database construction. It is necessary to choose a database model. We want to construct a database, we need to choose some models. Okay now, for example, we are using, we want to construct a database, we are using relational database models. Okay, ER models, entity relationship models. Okay na, that is the, we can choose the models. When doing so, consider the following. So here we need to follow these things. It should be well known model. When you are going to choose a model, elanti model మనం choose చేసుకోవాలి, it should be a well known model. Okay, it make replacing one database implementation with another relatively simple. So when we want to replace that database, it will be simple, relevant to the particular implementation, and it should allow for efficient queries. So whatever the model we are using, we are replacing, it allows the more queries from our side. which is important given that source models can be quite large. Okay, and also it should support remote access of the database. It will be support for remote access of the particular database from one or more geographically distributed user interfaces. We want it mainly support for remote access to the database from one or more geographically distributed user interfaces. It supports view fusion by combining information from various tables. Okay, now these database, these models will be support for view fusion. Why? Because the view fusion is nothing but what? It's combining information related to the various tables. Okay, now that is the importance of the particular models. That's why we can select suitable models and standard important models. These models, it supports query languages. For example, in database we are using structured query languages. Okay, na? Query languages that can express architectural patterns. Checkpoints should be supported by implementations, which means that intermediate results can be stored. This is important as an interactive process. So these models are useful for interactive process, so that it gives the user the freedom to explore with the confront that changes can always be undone. Okay, na? So that is the main important. Okay, na? It's provide the interactive important to an interactive process. Okay, na? It's always we give the freedom to the users to explore their views. They confront their changes. Okay, na? They can always be undone. Okay, na? The daily workbench. Okay, na? Already we know what is the workbench approach. This is the name, the daily workbench. For example, it uses a relational database model, as I said previous, relational database models, models. It converts the extracted views. It converts the extracted views into the regi standard form. Regi standard form. That is the main use of this workbench. And this format is then read in by a Perl script and output in a format that includes the necessary SQL code to build the relational tables and populate them with the extracted information. So that is the main use of this daily workbench. Next, when the data is entered into the database, two additional tables are generated. Whenever we are entered this data into the database, two additional tables are generated. What are those two additional tables? One is elements and second one is relationships. Elements and relationships. These list the extracted elements. So these are elements list the extracted elements and relationships respectively. Here, the workbench approach makes it possible to adapt new tools and techniques. So here, the workbench approach, whatever the information is captured, is going to store in a particular database according to the elements and their relationships. It will adopt some special tools and techniques according to the new approach, other than those currently available. Rather than currently available. So to carry out the conversion from weather format and an extraction tools used. According to the format, the tools will be used. For example, if a tool is required to handle a new language, it can be built and its output can be converted into the workbench format. That is the main use of it. For example, when we are using these tools, if we are using these required tools, these tools are handle a new languages. It can be built and its output can be converted into the workbench format. If the current version of the Delhi workbench, the Postgres relational database provides functionality through the use of SQL and Perl for generating and manipulating the architectural views. So the Postgres relational database, now they in this particular Delhi workbench they are using this version for providing functionality through the use of SQL and Perl for generating and manipulating the architectural views. Changes can easily be made to the SQL scripts to make them compatible with the other SQL implementation. That is the main use of these workbenches. For example, here we can take, for example, create table calls. We are using caller text and call EE text. Okay, and create table access. So we want to access table, function text and variable text we are using. Create table defines underscore variables. We want to define variables to create tables. File text and variable text, we have to write the syntax like this and so on. So you want to insert into calls value. So main and control we are using, and insert into calls values again main and clock. And like this we can, and also insert into access value we can use main and start one, where from where we can access we need to give the numbers. Like this we are using different types of symbols to create tables and to access tables and to define table, to insert calls values, to insert calls values to according to the clockwise, and to insert access values. So view fusion. So what is view fusion? Already I said what is view fusion. Among different types of views, we can combine different types of views. We will get different types of results, or we can express different types of relationships. That is called view fusion. So okay, according to the database, we can view the data among different types of tables. That is also called view fusion. Okay, a simple we want to say. According to the here, we can define view fusion involves defining and manipulating extracted information. So the view fusion is used to defining and manipulating extracted information for now stored in a database. Whatever the information they stored to reconcile. We want to reconcile the information or extracted information and manipulating the information. That process is called as view fusion. And argument and establish connections between the elements. We want to reconcile, we want to augment, we want to establish the connections between the elements. So that procedure is called as view fusion. Different forms of extraction should be provided complementary information. So whatever these different types of forms we are using, they will provide a complementary information. That is simply we have to say what is view fusion. Next, reconstruction. At this point, the view information has been extracted. So whatever the information were extracted, that can be extracted already and stored, I mean that is data reconstruction, and refined, that is view fusion, or augmented to improve the quality. So that is reconstruction. We want to improve the quality at this point. So what is that is already extracted. The view information has been extracted, is already information is extracted and stored. That is data construction, database construction, and refine and augmented, that is view fusion. To why? Because these are all, that is for reconstruction. What is the main use of this reconstruction? It's improve its quality. We want to improve the quality, that's why we need to reconstruct. Where we reconstruct at this point, so we have already we are extracted, already we are stored that, and already we can refine and augment it. So that is reconstruction. The reconstruction appears on views to reveal board and chorus granted insights into the architecture. And reconstruction consists of two primary activities. What are those? Visualization and interaction. Visualization and interaction, that is the one primary activity. The second one, patterns definition and recognition, that is the another one. First one, visualization and interaction, and second one, pattern definition and recognition. Okay, now here the visualization and interaction provides a mechanism by which the user may interactively visualize. So that is the main thing. That is the user point of view. The user visualize the particular information. The user interactively visualize the particular mm, information. So they are using this particular visualization and interaction mechanism. With the help of this visualization and interaction, this mechanism provides by which the users may interactively visualize and explore and manipulate the views. With the help of this activity, the user interactively visualize and explore and manipulate the views. In daily views are present in the users as a uh, architecturally decomposed graph of elements and relations using the Regi tools. So when we consider these daily app workbench views, these views are presented to the users as a hierarchically decomposed and a level-wise decomposed, either generalization way and specialized way, means a top-down approach and bottom-up. In which way we want to visualize the data. So these views are very useful to present the users as hierarchically decomposed graph of elements and relations. So using this will be use useful with the help of Regi tools. These all things are getting with the help of different types of tools. For example, these Regi tools. That is the reconstruction. So what is reconstruction? So simply we have to say, at this point the view information has to be extracted and stored and refined and augmented to improve its quality. The reconstruction mainly operates on views to reveal board coarse grained instead into this architecture. That is a reconstruction. So here we want to reconstruct. It consists of two primary activities. What are those? Visualization and interaction. With the help of this visualization and interaction mechanism, the user is interactively visualize and explore and manipulate the views. And pattern definition and recognition means which patterns, which trials how to define and recognize the things, it will be useful. Here the mainly we are using the particular daily workbench mechanism. This will be used to views or presented the users as a hierarchically decomposed graph of elements and relationships using the particular Regi tools. That is the main use of this information. So I hope all you understood these concepts, why we need to reconstruct the software architecture. So in this session we discussed about so many concepts. So this is very important concept. From this we will get definitely one question in the end exams regarding to reconstruction of software. For example, what is information extraction, and what is reconstruction, and what is view fusion. View fusion for so many times is asked for 2 marks question. Define view fusion. Okay, now in this we are discussed about reconstructing software architecture among its introduction, and we discussed about workbench approach in the last class and reconstruction activities. So and what are the points we are reconstructing, and we can discuss the block diagram of particular architectural reconstruction activities in the last class. In this class we discussed briefly about information extraction. What is information extraction, how to we extract the information, which type of tools we are using to extract the information. So and also we discussed about different variety of tools we are using, like parsers, abstraction, syntax tree analyzers, lexical analyzers, profiles and code instrumentation tools, and ad hoc tools. We are using different types of tools for extract the information. Okay, now and also we discussed about database construction and how we can reconstruct the data with the help of some standard formats. So what is the use of this? We want to form some standard format to store the particular extracted data. We using some such type of database model. So necessary database models we can choose. So why we need to choose the particular database models? So what is the importance of particular database models we saw here? Okay na, importance of particular database models. Okay na, and also we discussed about view fusion. What is view fusion? And briefly we discussed about what is reconstruction. Okay na, how we can reconstruct the data. Forget quality, we want to get the quality, we need to reconstruct the database or software architecture. Okay na, so here we are discussing about two primary activities. One is visualization and interaction, and pattern definition and recognition. I hope all you understood regarding reconstructing software architecture with the help of reconstructing activities. Like, what are those four types of reconstruction activities? First one, information extraction. Second one, database construction. Third one, view fusion. Fourth one, reconstruction. Thank you one and all. Up to here the fourth unit is completed.